Okay, so we are going to be starting Module 2 this week. So tonight we're going to be looking at session number 1. So we'll look at the agenda items here in just a little bit. You'll notice for Module 2, there's going to be 3 things to hand in. There's going to be a set of practice problems. That's going to have to do with AutoCAD and the tutorial that we're going to do the next time we're together. So nothing for that tonight. Assignment 2A is what we're going to actually be able to finish or able to start working on with all the information that we get from the lecture this evening. Okay, so 2A is about the textbook, the tech drafting textbook. And then 2B is going to be AutoCAD like assignment stuff. Okay, so what we're going to do is I'm going to go up to session number 1, agenda items. And those who are virtual, if you want to turn your camera off now, it's totally fine. I'm gonna do the same. And then it doesn't take up room on our screen here. So you're going to notice here that we're going to be looking at both chapters 3 and 6 in our like big chunky textbook. Okay. We're going to be looking at visualization and sketching in module 3, and then starting orthographic projection, which is how we lay out views, if you would, on an official technical drawing for mechanical purposes. Then we will be looking at this orthographic projection practice. So this is basically going to be our assignment 2A. It is our assignment 2A. So for those who are in class, I do have it printed, but I'll be getting you started on this so that you have a taste of what's expected on each one of the parts of that handout. So there's multiple parts, multiple pages, and some exercises for you to do, practicing the things we're going to learn here in chapters 3 and 6. Okay. So what I'm going to do is I am going to open up that first PowerPoint presentation. I'm going to make it a little bit smaller. This is chapter 3 again from our tech drafting textbook. Now, for the most part, all the illustrations are here. The only reference I'm probably going to do is going to be on page 79, I believe. And that's going to be a little bit later as we get to something that we're going to actually sketch. So, but for right now, most of the items are here in the PowerPoint. So in chapter 3 here, we are going to be kind of learning some vocabulary techniques and doing a little practice sketching. Now, sketching is going to be kind of that first step in the design process, kind of getting what's in our head down on paper in sketch form. Okay. So we're going to point out some things, and you might think, well, it's a sketch, there's not much to do. But honestly, a sketch is kind of where everything starts. Sometimes you give somebody a sketch. Could you make this real quick so that we can just test this out? And you might not take the time to do it in, formal CAD form and put all the dimensions on and figure out all the tolerances, but it's kind of a quick prototype, if you would. Like, let's see if this is going to work. And if it does, then you'll kind of refine the design. So sketching becomes kind of important. And as far as our advisory committee, at all the programs here at WCTC have advisory committees that are made up of industry representatives, and they work in the jobs that you guys are, potentially seeking once you graduate from our program. So we have actively working design engineers, CAD layout people, and things like that. And they review certain things about our curriculum. And one thing that comes up and they say is very important as somebody who works out in industry, you've got to know how to sketch, how to kind of relay your ideas in a graphical mode without being super formal about it. So that's why we spend a little time here kind of, talking about sketching and what you want to be aware of. So I'm not going to read all these different things to you. We'll just kind of get into it. Now, so why is it important to be able to sketch? And I kind of touched on that already. Sketching is a valuable tool that's going to allow you to communicate your ideas quickly and accurately. Okay. As we know, a picture is worth 1,000 words. Sometimes we can kind of explain and point and, that kind of thing. And it's like, what do you mean? But a sketch all of a sudden kind of clears a lot of things up. Sketching is a really efficient way to plan your drawing. It's a good thing to do before you actually do the drawing because it helps you to be more accurate, just like any plan. If you plan things out ahead of time, you plan your list for the grocery store, you don't buy a lot of stuff that you don't need, right? So kind of the same thing with sketching. It creates a little plan for when you actually make the official drawing in like a CAD system. Usually if you complete that plan, that sketch, when you do that design, you'll probably design it a little faster and then probably with fewer errors as well. You'll forget fewer things. So all good reasons to know and understand how to sketch. Now, Some terminology here that not necessarily related to sketching, but to items that we're going to come across here in mechanical design and in drafting and such. So as we look here, there's a couple different things on an object that we should be aware of. So a planar object or the plane on an object. A plane is going to be anything that is kind of a flat surface, continuous surface. So if we look at this top item here, the green, there's a top surface, there's this back surface on that cutout, the side surfaces. So there's a lot of different surfaces a lot of times. And a planar surface just means it's nice and flat, okay? A single curved surface. So if we look at around the outside here, this is a cylinder. So the outside curved surface is going to be one that is going to be not flat or planar, okay? A double curved surface is going to be one where you have, in two directions, if you would. You've got a curve going around the circle, but then you also have a curve going around what I'll say the cross section. So you have more of a donut looking item as we see here. And then a warped surface. This is when you have something that's kind of, we usually call it a complex surface where there's a number of different contours that are going on. I think of a warped surface or a contoured surface. If you think about the inside of your car, there's a lot of curves and blends and things like that come together. And in a lot of cases, these surfaces that are complex, we no longer make drawings for. We make the model and we use the model to create the path with whatever manufacturing process is going to occur. So guess where that warped or that contoured surface starts? Who comes up with that model? You guys. You're going to get to do that as part of being a mechanical designer, a mechanical engineer. The software that we learn, not so much in AutoCAD. AutoCAD's a 2D system, but when we start getting into these complex, 3D curves, computer programs like SolidWorks are going to be like perfect for doing stuff like that. Okay. So these are the different types of surfaces that you can come upon. Now there's different types of solids. How many people played Dungeons and Dragons? There's usually a couple. Dungeons and Dragons. Yeah. Okay. Dungeons and Dragons, they use these dice that have different sides, right? And this is what this always reminds me of. I wasn't a Dungeons and Dragon player, but I had friends who did it a lot, and so I always saw their little dice. So all these different types of shapes. You'll see we have a tetrahedron, a tetrahedron, a hexahedron, an octahedron, and then the last two I'm not even going to try to pronounce, but they have 12 sides and 20 sides. Okay, so there's all different types of shapes that we come upon. We also have prisms. Prisms are when we have two bases, meaning that we can turn it over and we essentially have the very same shape on either side. So again, here are a number of different types of prisms that we see here on the top. An oblique prism is when we cut it off. So for instance, in the bottom here, when we have the right triangle, the right square, and the oblique pentagonal, it means that we're going to be in this case, kind of truncating it or cutting it off. Here we have some pyramids. A pyramid is going to be basically a triangle that comes together at one peak, and again, truncated in the case of the middle one. Cylinders and cones. A cylinder is basically going to be a circle that we kind of take and we lift up a distance. So, just a regular called a right circular cylinder, or you can have an oblique where it goes off at an angle. A cone is going to be something, as we see here, it's going to be circular at its base, but then it's going to come to a point on its top. Okay. Here's a couple other, types of shape. A sphere. We're going to come upon spheres when we have things that are circular as we look at it in any view that we have. So it's a sphere, kind of like a ball, basically. A torus is when we have like that donut type of a shape. And then we've got an ellipse or again, ellipsoid, I think is how you say it. And basically what we have is we have an ellipse that then if we would rotate it about its center, we would have then another curvature in the other plane. Let's talk about edges and vertices. Okay, edges and vertices. So we have a simple block here that has a cutout in it. Now an edge is going to be anywhere where we see two faces coming together. So an edge would be found here, here, the back side. So a number of different edges where we have two faces that come together. A vertices is going to where we have actually three edges or more that come together at one point. So here, if we look at the corner, like the top corner here, this is a vertice because we have 1, 2, 3 edges that are coming together to create this point. Okay. Same thing on the back. And then it would be on the bottom of each one of those and so on. So we've got a number of vertices as well. And then you're going to notice we have faces. Faces are going to be just those flat planar surfaces that then come together at different edges. And then lines and points. So a single line element could be an edge, okay? A point would be the vertice, where everything comes together. 1, 2, 3 edges come together at that one point, which is a vertice, okay? Also called a vertice. Now, points and lines. Points is used to represent a location in space, but it doesn't have a width, a height, or a depth, okay? It's literally just this one little point right there. Now, a point can be identified as like a crosshairs. We see that a lot with a point, okay? We could also place a point along a line, or it could be a midpoint or an end point on a line, okay? Or where we have two lines come together, we could find an intersection, and that would be a point, okay? So points are specific places in space. Lines, I know it's hard to say, to identify a line without saying the word line. So as we look here, line is going to be used on a drawing, and most often it's going to represent an edge that we actually see. So we're going to see that when we start to visualize things or draw a view of something, we need to identify with solid lines, what are the edges and the shapes that we actually see when we look at it in this orientation, okay? So lines we're going to be using a lot. Now lines, you know, can be a definite length. So we can measure the length of a line. So you're going to notice here, lines can be straight, lines can be curved, lines can be offset from one another, lines can be perpendicular to each other. So, so many of these things you're going to, you know, notice about lines. Now an angle is going to be, an angle is formed when you have two intersecting lines. Now, if those two intersecting lines are 90 degrees to one another, we don't dimension them. So like right here, you see a right angle. If we would be showing the orientation of two lines at 90 degrees to one another, we never dimension, it's assumed, okay? As long as that's the case. If it's 91 degrees, now we're dimensioning it. If it's 89 degrees, we're dimensioning it. But if it's 90 degrees, those are assumed angles all the time. Same thing with 180 degrees. We don't dimension 180 degrees. We just draw it as a straight line, if you would, okay? But anything else, less than 90, more than 90, we're going to be dimensioning. Okay, and now you might be wondering, why are you telling me about dimensioning already? Well, we're going to be dimensioning pretty soon, probably starting next week. So I might as well kind of show these different things here. So the angle is going to be basically the orientation for which we have between two lines. Okay, how many degrees is, you know, separates those 2 points or those 2 lines. Drawings and sketches. The following are important skills to keep in mind when you're sketching drawings. Okay, so first of all, accuracy. We are sketching, so you don't have to worry about being right on or real precise. But what you want to do is you want to make sure that you represent it in a way that's proportional, okay? So that you can kind of get an idea of what it is, okay? Speed. Time is money in industry. You want to work smarter and learn to use the techniques and to speed up the sketching, so that when you go to CAD later on, you now can take your time and be more precise, okay? The CAD system is going to have the ability to be nice and accurate. We can hold, well, for instance, in AutoCAD, 14 decimal places after the decimal, okay? That's really accurate, okay? We usually are interested in 3, 4, 5 decimal places if we're machining-ish, okay, depending on the capabilities. But you don't have to sketch that accurate, okay? You just have to be able to put things in proportion, have reasonably straight lines, okay? If you don't, then just use, you know, grab out a straight edge of some sort. But you want to be able to kind of do it relatively quickly, pretty accurately, proportionally, okay? Now, legibility, the drawing is a means of communicating an idea to each other. So at that sketching level, remember, these are the very early stages of the design process or even prototyping. Like I said, it might be something that you give a machinist, like, could you quick make this part for me? I just want to try it out. I want to see if it's going to work, okay? And you have to make sure that they can read it, okay? So you can't chicken scratch. You know, you're going to have to take time to write the dimensions in place, make sure that they know where the dimensions are going to. So, you know, putting those things in place and any notes that you think are really important. Again, it's not going to be the final drawing, but you want to make sure that your idea is being conveyed in a way that, you know, you're going to get what you're asking for. And then it says here neatness. So legibility and neatness, I think, go hand in hand. You want to make sure that it's readable and understandable. Freehand sketching. So on I guess it's the 14th slide here, we have a part, okay? And this is a part, and they have two views of the part. So number one, you're going to notice that as we look, and I'm gonna zoom in a little bit, okay? I'm gonna zoom in just a little bit here. You're going to notice that as we look, these are not perfectly straight lines. So they didn't use a straight edge when they created this, all right? But you can see the faintness of like grid paper in the background, okay? And that's why for our exercise today, grid paper is nice. You don't have to have it. So if you're virtual and you don't have grid paper on you, but it is kind of nice if you're trying to sketch something that you want somebody to make, even if it's not the official CAD drawing, it helps you to kind of, you know, get proportions and then keep things in line. We're going to find out in chapter 6 when we talk about orthographic projection and laying things out that we have to be in line across the views with all of our elements, okay? So you're going to notice here that around the outside here, they did not use a straight edge, but it's straight, and using those grid lines in the background, they're, you know, nice, and you can tell that they're supposed to be straight. Same thing with the circles. The circles look pretty darn good. Now, if you're not a big fan of drawing circles, I'll give you, you know, some hints a little bit later on how to draw them, but circle templates can help you a lot, okay? I told you when I was, and I'll put these underneath our cameras. So like a circle template like this, okay? I had a ton of different templates when I was in your shoes. At that time, like I told you, the reason I signed up was because I really wanted to draw like the rest of my life. And instead of being an artist, I wanted to do mechanical drawings. And I got to have all this cool stuff, all these cool templates and erasers and pencils and brushes and big drafting boards. It was like the best, but never got to do it, but that's okay. That's all right. Instead, and I think I've told you this before too, the time when I was going through this, it was when CAD systems were being introduced. Okay. So I really got in on being a CAD operator out in industry and taking manual prints that were drawn by hand and converting them over to a CAD system. So that was an interesting time. So anyway, you can use templates and things like that to achieve some of these things. But again, as long as you can reasonably sketch a circle, you're going to be fine. Okay. And if you need the circles to all be the same size, so you're going to notice down here, there's a little dimension. It says 6 by. That means that there are 6 holes that are all a diameter, which is that circle with the slash through it, of 1/4 of an inch. Now, you want to be sure then that if there are 6 holes here, that they all are about the same size. If you have a couple more holes, you want to make sure that if they're not the same size as 1/4 of an inch, that they're noticeably a different size then. So again, that's kind of where the accuracy comes in, or the proportions come in, so that you can see which ones you're talking about. You're also going to notice that they have some good dimensions on here. Again, there's no straight edge looking here, and proportions. If I would go in and I would probably measure this is probably not super close to 2 inches. It may not even be close to 2 inches, but proportions wise, here's the 2 inches. And then beyond that, 2 1/4. And, you know, the overall length here, I think it's down here, 3 inches. So you just want to make sure that things look the way they're supposed to. Okay. And again, that they're readable. You're going to notice that a dimension is going to have a number. That's going to be the number associated with its length or height or width, whatever it might be. And then it's got 2 lines with arrowheads on either side. And then there's extension lines coming up off of the feature that we're dimensioning to and from. Okay. Lines. Okay, there's all different types of lines that we're going to use on our drawing. So first of all, construction line. A construction line is going to be something that we kind of sketch in the background, and it's going to be used just for that. You're going to notice that when we use AutoCAD, there'll be times when we have a layer. This will be a little bit later when we create layers and different line weights. One of the layers is going to be a construction line layer, and it's going to be a real light line, okay, that we can put in the background, and then we use it to kind of sketch over the top of or put our more solid lines on. The next one that we see here is a visible line. A visible line is going to be the line on our drawing or on our view that is going to be the most prominent, and it's going to be something that we physically see. So it's going to be the outline of the part. It's going to be an edge. It's going to be a circle that we see the edges of that circle as a true circle. When we need to depict hidden lines. So sometimes when we look at a view, we're not going to see a feature that might be into the material, okay? And in that, we still want to recognize that there is something inside of there. And so we draw what we call hidden lines to represent those features, okay? So we'll be using hidden lines, and those are just simply evenly dashed lines. Here we've got a dimension line. So this is going to be, a dimension is going to be something that's going to give us a number or a size of something, and we're going to have a straight line, and dimension line always has two arrows. Where am I going from and where am I going to? Always, okay? Every dimension has two arrows. An extension line is going to be extending off of a feature so that we can dimension to it, okay? Center line is going to have one short line and then a long line, then another short line and a long line. So it's not even dashes like the hidden lines. And center lines are going to depict the axes or the centers of circular features, okay? So we're going to see center lines. Now a phantom line, you're going to notice here, this has two small dashed lines, a long line, then it's going to be two small dashed lines and a long line. Phantom lines are used to draw items that are probably not, and this is mostly assembly work that we would do. Let's say we're creating a fixture to hold a part when it's being drilled, okay, on a milling machine. The phantom line is going to be there for things that we have to avoid. So we might draw, for instance, the end of the milling machine so that we know where it's going to be mounted to. It might be where the spindle is coming down so that we make sure that our fixture is low enough profile so that it doesn't interfere with something that might be there. On an assembly of maybe a packaging machinery, it might be maybe another element that we have to be sure that we cannot collide with when we're operating the machine. So phantom lines are kind of special cases of things that in an assembly we want to be aware of it, but it's usually there to make sure that we design around it. Does that make sense? Okay. It's not going to be part of the current assembly, but it'll be part of when we assemble it or part of when it's going to be working. The last two are cutting plane lines. The last two, we can have a cutting plane line in one of two ways, either using a dashed line like a hidden line, but notice it's very thick, or we can use a phantom line. Now, something you will notice is that a construction line is very light. So we would say that's a very small line width, okay? A visible line is darker. So the line weight or the line width would be thicker, okay? Hidden lines are thinner or less line weight than the visible line. So when you would do this with pencils, for instance, you would press harder or you would use softer lead to make the visible lines on the outsides of or the edges that we would see in a view. If I was then switching over to hidden lines, I would have a different softness or hardness of a lead so that it would be harder and it would be a sharper line so that it would be less prominent than the visible lines. So it's the kind of same thing with the center lines and the extension lines as well. We don't want to emphasize these elements, but we do want to emphasize like the visible lines. When we're using a CAD system, what's nice is we can set that all up and we don't have to kind of worry about it. We just then select that line type per layer in AutoCAD, and then it's automatically going to set it to the wider line weight or the lighter line weight, depending on the type of line that we're going to be using. Good and poor techniques. So here you're going to notice that, and I think it's always good. The book does this, and I think they do a good job in most cases. So on the top here, you're going to notice these are good examples of sketching. Now, you are going to notice that they probably use a straight edge. And like I said, straight edges are optional for sketching. If you can draw a reasonably straight line that somebody can say, that's straight, you're good. But if you know that you're not so great about that, you can just grab out literally a straight edge on anything, you know? So if it's on your circle template, or if you have a protractor, or you have a scale, you can grab out a straight edge. I mean, you might say, well, that's not really sketching, but you want to create a straight line, then you use that if you're not really good at it. Notice here when you draw hidden or dashed lines, they're even distance apart, okay, as close as possible. Again, sketching. Same thing with our center lines. We want to have a small dash line, then longer, and try to keep those even depending on how long they're going to be. Now, when we look at the not so great illustrations here, you're just going to notice that the corners aren't like nice and crisp, kind of light lines that are coming in. They're not too visible. When you look at the corner here where the radius that's coming in, you're going to see that you're not lining up really well. Again, you want to do it for whoever your audience is, and make sure that they can understand what you're trying to communicate. So line weights, we talked a little bit about that already, so I'm going to just kind of skip over that. I'm de-emphasizing, I'm not saying that sketching, I told you, it's an important skill to have, but we're not going to be drawing on a drafting board. Okay, so I don't want to worry about different types of line weights and things like that, because you're not going to do it all that often. Sketching straight lines, we don't want them to kind of tail off. Okay, that's really it. We don't want to have a lot of wiggles in between. So again, if you know you're not too great at drawing a straight line kind of freehand, then just grab a straight edge. That's all. It's not cheating. You don't get less points. Somebody's going to appreciate that you took the time to do that, actually. So you just want to make sure that again, it accurately reflects what you're trying to do. Proportions, maintaining proportions. And this is probably the most important part about sketching. As I said earlier, let's say I have a part and the part is only 4 inches long. It would be about this long, okay? But I want to give it to somebody and I got to add some dimensions to it and stuff. And if I only make it 4 inches long and there's some other features on there, it might get kind of crowded, right? If I sketch it, I could sketch it 8 inches long or 10 inches long and make it as big as I need to, so that the proportions then are going to make sense for whatever details I have to give it, okay? Sketching is just that. It's relaying that information. So you don't have to worry about, oh, it's supposed to be 4 inches. You can sketch it as big or as small as you want. That's going to make sense. Let's say you have something that you want to be 3 feet long and you only have a piece of paper this big. Well, you're not going to tape together 4 pieces of paper. You're going to put it on one, but you're going to proportionately then put the other features on there. Does that make sense to everybody? Okay. So that's going to really be kind of the key. So this is going to be kind of our practice here in class. We are going to draw this part. Okay. We're going to draw this part. Now, they have dimensions on here. And I don't want you to worry about the dimensions. We're not going to add any dimensions to our sketch. We're just going to sketch the profile and the 3 holes that are here. So I want to kind of just walk through a process with you. Now, in your book on page 79, they kind of go through this process, and I think they do a good job, but I know that we can approach it all different ways. So what I'm going to do is kind of talk us through. I don't want you to really draw just yet, but I just want to talk through the steps that they suggested here. And then we'll all take a little time to sketch, and then we'll kind of, meet back and see what we have. Okay. So it's on page 79 in this box right here. And it says, sketching a single view drawing. So we're, again, just going to look at the profile of that part that we have on our PowerPoint, but it's also up here on page 79 at the very top. Okay. Page 79. Now, the process that they take right here in step number 1, they're just going to lightly sketch the center lines for kind of the main elements. And those main elements are going to be the center line for where this hole and this larger radius is. So that's kind of one end. The center line for this middle small hole. And then the center line for the right end, the radius and that hole there as well. Okay. So that's all that they did. They kind of just identified where those center lines are. And these are construction lines. These are lightly sketched at this point. Then what they did is they went ahead and they were again trying to proportionally put in here, okay, if the center is here, how tall and how tall up and down on each side of that center line do I have to be? And by having grid paper, what's nice about that is that we can actually, count, okay, if I'm going to go up six boxes, then I can go down 6 boxes and kind of ensure that it's going to be, in line with each other or even on both sides. And then you're going to kind of see that they then did that on this end as well. So no radiuses just yet, kind of planning out all construction line stuff. Okay. So kind of getting the rough outside. Then you're going to notice that they added the radiuses. Okay. So they added the radius for the outside here, the radius on this side. And then these are radiuses for, I'm going to say, the fillets that are on those internal corners there as it steps down to the smaller part. Additionally, they put the circles in place, okay? And then you're going to notice after that, then they kind of darkened in what is the, actual profile. So you would darken in this outside portion. Those become those visible lines. They're the ones that are going to create the profile or the perimeter. And then also darken in any edges that you would see. Now, in this case, you're going to know that you're going to notice that the circles and such kind of faded into the background. Now, just a little history. It's not really going to affect you or anything, but I don't know, maybe you'll go to a company and there's a blueprint reading machine or a blueprint making machine. When I started out in industry, if you were doing anything manual, all these drawings were on something called vellum. They were kind of like I don't know, kind of like a tissue paper, but kind of see-through-ish, okay? And what we would do is you didn't ever give that vellum piece of paper, that vellum drawing to anybody out on the shop floor. You would run blueprints. And I'm sure you've heard of blueprints before or seen blueprints. A lot of times you see them in terms of like architectural drawings and things like that. Well, we would do that for these as well. So these vellum drawings would be kept in a drawer in an engineering department and they would catalog them. And then when you needed that drawing, you would get the copies made on the blueprint reading machine. I hope everybody is following along here because it looks like there might be people working on the homework assignment. Sometimes when we decide to work ahead, you might have to redo things because you might not be doing it the way I want you to. Okay, so it's to your benefit to follow along because the things that we're talking about here are going to lead into that assignment. So maybe I regret sometimes putting my assignment out because anyway. So please follow along. I'd really like everybody's attention because there are things I'm talking about that probably will come up for you. Well, anyway, so then you did a blueprint would go out to the shop floor, and the blueprint would only recognize these dark lines. So you never saw on the blueprint somebody who was reading that print to actually make it. They never saw the construction line. So a lot of times you'll see that construction in the background. So that's kind of where the sketching kind of comes from. So what I want you to do is, if you haven't already done so, there is, and it doesn't, if you're virtual and you don't have grid paper, what I want you to do is kind of go through that process. Now, if you want to, make it your own, that's totally fine. But we'll kind of go over it after I give you a couple of minutes. So again, if you don't have grid paper, you certainly can just use paper that has no lines on it. So if you're virtual, that's totally fine. But just go ahead and sketch. And what I'll do is I think it's easier to look at this for the kind of overall. Now, again, we're not looking for accuracy of dimensions, proportions. Okay, so on the end here, where it's a radius of 30, okay, and over here it's a radius of 18, you want to make sure the 18 is smaller than the 30, right? When you look at the placement of the holes, the edge where it drops off and it's going to go down, you want to make sure that that's after that small little hole, okay? Because that's over further. So proportions. So go ahead and take time to create a sketch of this profile. And then once you kind of get your shape, you're going to want to kind of darken in those lines that you can. And then I did have a circle template that I could put my circles in, but I just wanted to show you a quick technique that if you wanted to kind of, if you don't have a circle template or you don't have a compass, for instance, to put the radiuses in, you don't have to worry so much about it. But what I usually do is I mark off my distance over. So for instance, I knew that my width here was going to represent that 60. So I went up 1, 2, 3, 4, 5. And then I went down 5. And then that means if I'm going to strike an arc, okay, that means over to the left, it's going to be 1, 2, 3, 4, 5 out here. So I made a little point there. And then now all I'm going to do is I am going to kind of draw, and I have something that I can kind of get to. So I can make it go to there and then kind of lightly see if I can get over to this one. And again, it's not going to be perfect, but it gets you a little bit of a radius. Okay. Kind of the same thing on the right-hand side. I went up 1, 2, 3, 1, 2, 3 down. So then I put this 1, 2, 3 out. And then again, kind of lightly put my radius in to start. And then I can darken it in for the final visible line, again, as a sketch, so somebody can see that it's a radius. Certainly not perfect. And then we would want to do that same thing for the fillets that are going to be on those corners. Okay. Now, again, I have a compass set from when I did this many years ago. You probably don't have a compass set hanging around. That's why, you just do your best with the circular features. Okay. How'd you guys do? You okay? This is for your eyes only. It's just a practice. That's okay. I know sometimes not so great. It is a skill that you develop, right? If you don't do it all the time, just like penmanship, if you don't hand write a lot, and you type more often, you may not have awesome penmanship, right? But the more you practice, the more you're good at it. And the assignment that I have for you, you will be practicing. Okay. Any questions about kind of that process? And again, you'll notice that I'll kind of zoom in here. My construction lines are still kind of on the edges here. Okay. I didn't get those out, but they were light enough that once I darken everything in, you really don't even notice them, right? So if I wanted to put a couple dimensions on here, hand this to somebody, hey, could you make this out of 1/4-inch steel for me? I want to test it out. They could do it, right? And you've got some good proportions there that's readable. Again, we would be adding some dimensions and kind of, that kind of thing to get them the sizes that we would be shooting for, but it's a nice, clear sketch. Okay. All right. You guys having fun? It's kind of fun to do it, I think. Yeah. All right. Okay, so like I said, that's for your eyes only. You aren't going to need to hand that in. So let me go back to my PowerPoint. I should check in. Those who are virtual, you guys do okay with that?
Yep, it's okay.
Yeah, all good.
You're good? Okay.
Yeah.
Awesome. Awesome. Okay. All right. So we're gonna go a little bit further now. Projection methods. I'm going to zoom out a little bit so we can see a little bit more here. There are a couple of different types of projections that we can take on parts. So in this case, you'll notice that there are 4 principal types of projections. 2 of them are going to be the ones that we're going to exercise on a regular basis. One of which is the one that we're going to practice most in this class. So the one we're going to practice most in our class is going to be multi-view projections, okay? So as we look at our very simple block that we see here, what we're going to do is we're going to position that block so that we see a flat plane in front of us and that it's going to project directly back. So it's kind of like we call it this plane of projection. You see this like I'm going to call it like a little glass piece of paper that I can kind of see through, okay? And I'm looking straight on to that block, okay? If you've ever industrial arts in high school, they usually have you maybe draw your house or draw, stand it right in front of your house and show what you see, or go on then the right side and see what you see. And normally in architecture, they call those elevations, right? Or you would look down, like you would be looking at it from a plane, looking straight down on the roof of your house. What would that look like? Those are projections where we're 90 degrees from where we're at. So we're standing right in front of something and we're going to draw what we see. Okay. And that's what you see here. You see them projecting these lines that are parallel to, if you would, our piece of paper to draw the perimeter of the profile. Okay. Now we would do that not only in the front, then we would change our perspective. We would go to the right side, the left side, the top, the bottom, the back, and we would draw what we would see in each one of those views. Okay. That's going to be what we're going to be practicing most often, all the time here, from today until October 10th. Okay. Another type of projection that we will see is going to be a perspective, or sometimes we refer to it as an isometric. And all that is I like to say it's a pictorial of what we see. In this class, we won't be doing those because when we get to SolidWorks, which is going to be next term for you guys, you're going to create models. The model, you start at the model level, you have the ability to, I'm not going to say automatically create, but you can create the orthographically projected multi-view drawing. And then you can add a nice little isometric up in the corner so that you can have an isometric to give you good visualization of what that part looks like. And then the multi-views that you have that are orthographically projected, we're going to find out, those are going to give you the details of all the things that you need, okay, as far as manufacturing that part. So we will get this as a product of the models that you create in 3D parametric modeling. So we won't be focusing on creating those. Our focus is going to be right here on a multi-view drawing where we're looking straight at, like, what's the front look like? What does the top look like? What does the right look like? And keep switching our view 90 degrees so that we can get a good practice on that. Now, we're going to do a little bit more sketching, okay? So we're going to go to page 117 in our tech drafting book. I hope it's 117. It might be a little different. Yes, it is 117. Good, 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 good. And we're going to create a single view sketch of the following. So you'll notice that the letters that I'm identifying are B, E, H, and I. B, E, H, and I. If you need another piece of graph paper, go ahead, or you can, you can turn your paper over and do these. So B is here, and I'll pull this up in case you don't have it. B, E, and then H, and I. Now, what we're going to do a single view for each one of these. The way that they're sitting, we're going to look just in one direction. It's just going to be front view only, okay? Front view only, like looking at it in this view, looking at it in this view. And for H, it's going to be here. And for I, it's going to be here. So only looking in that view. We're not going to look right side, top view, or anything like that. We're just looking in one direction, practicing sketching. So I'll kind of put B up here first. We don't have any dimensions, so this is where you're going to be looking for proportions, okay? Proportions. So if you need to grab an extra piece of paper, go ahead. And for those who are virtual, just, grab a piece of paper and do a little bit more practice. Does anybody need an extra paper? I usually make my stuff big, so usually need more. Now, some of these might be quicker than others, and that's okay. Now remember, if you see an edge, you're going to draw it as a solid line. Okay. And then also, there'll be some here that have some hidden lines. If you're not exactly sure what to do with those, that's okay. We'll go through them all together. But hidden lines are for things that we're recognizing that are inside the part as we're looking at that view. We might not see all of the elements. So we use hidden lines to show those on the inside. Anybody needs to see the next one? Please. The last two, let's see what's over here. Anybody have any questions as you're working on these? I put 9 up here if you want to compare. We'll talk about them and I'll give you another minute or so. Wanted to maybe talk about hidden lines in E and maybe some edges in H. So virtually, if you have any questions, feel free to put them in the chat. So let's start looking at them, even if you're not completely done, that's okay. I'm going to start looking at the first one, B. B was pretty straightforward. It had, um, just that half circle at the top in the middle, and it was a rectangular box. So, basically just showing a rectangle, that half circle, and then you'll notice that I added the center line of where the center of that half circle would be, okay? Again, good practice. We put center lines at the axes or the centers of any circular features, including half circles or arcs that we see, okay? Most of the time too, we will dimension to those because when we create those in manufacturing, we need to know where the centers of those are. So it's usually where if it's going to be a hole or something like this, we position the spindle, where that center would be. Okay. So I added the center line. If you didn't, that's okay. Add it in. And the center line is going to be 2 short lines that are kind of like a crosshatch and then longer ones going out on the sides. Okay. And then we extend them a little bit beyond our feature itself. Okay. The next one we have is E. Okay. E was down a little bit further. It's this one right here. Now we're only drawing that front view, okay? But you'll notice that there's a hole going through, and we would assume, I assumed that was going all the way through. So that is what the hidden lines that we see in this view are. So we're not going to see that hole in that view because it's inside the material, but we want to recognize that it's there. So we show hidden lines. The only time we don't show hidden lines if it starts getting too cluttered with the lines and it's hard to kind of depict. But in this case, it's just these two. And so when we see a hole, it would go through and we're going to draw hidden line for the edges of the outside of the hole, okay? And then we're going to show a center line going down what would be its axis, okay, in the center there. Notice that the center line extends a little bit beyond the outside visible line of our part here, so a little bit beyond the extents of that hole and then down below as well. And it's a short line with a long line, short line with a long line, okay? And again, that's depicting the axis of what's a circular feature here. If we didn't show that as the axis, we would just have those two lines in the middle and they could really be any rectangular feature then, okay? But this lets us know it's circular. So we would be looking in another view for, you know, the size of that hole, if you would, that would go through. And we would see that in a top view. Now, as we move over, you're going to notice there's an edge here because as we look, we're going to see this front edge because it's a head because this is recessed back, okay? So we would see that as an edge. And then we've got our hole that's in that little ear, I'll call it. And then again, I showed the, you know, center line so that we could then, next step would be to dimension to that center line. Okay, so two short lines, crosshairs, and then the longer lines going, extending beyond that hole a little bit. Any questions on E? Okay. The next one is H. Okay. Similar to that first one where we've got the half circle on the top, I stuck my center line here kind of in the middle, right? So again, I would probably anticipate creating a little dimension there. And then you're going to notice that on this one, the ear in the front is part of that front plane. So there is no line going down here. It's a continuous surface. But over on the right-hand side, there is an edge here because that foot is recessed back, okay? So you'll notice on my drawing, when I look straight on, this is all part, it's a continuous surface, so we don't see an edge here, but we do see an edge over here, all right? And again, I was having trouble getting my circular and my center line in there, okay? Any questions on that one? Right. And then the last one, I had to do this one twice and it's really still not okay. Yours look kind of, so in this case, I tried to make it proportional. I wasn't too good at making my holes the same size on either end, but I'm relatively close. So again, it's a skill that we perfect and we work at. I probably would have, if I had them, and I do have them here, but probably want to use some compasses or something like that for the profile. But this would be what this one would look like at, you know, the edges that we see, kind of the donut, if you would, the two edges of the inside and the outside of that bore that's sticking up, and then the profile of the part that's going back. And then adding some center lines here. No hidden lines in this one. Any questions on the last one?
I had a question for H.
Oh, for H. Yes. Let's go back to H.
On the bottom left, why isn't there a hidden line?
Why isn't there a hidden line? I guess, oh, do you mean from, oh, did you read that? And maybe, I guess I would see how that could potentially. So what you're seeing is this wide, right? And this
Yeah,
is shorter.
I'm
So,
assuming I
so
saw
you're
as the same.
assuming it's going to be halfway back or something, correct?
That's what I was seeing.
Oh, okay. All right. Yeah. Then in that case, there would be a hidden line here. I guess I didn't interpret it that way, but yes, you
Okay.
see what he's saying there. Did anybody else do that with a hidden line? I guess I didn't see that level of detail, but now that you're saying it, that does make sense. So notice how the depth here is this wide. We're not given any dimensions, and this one is only like that. So it's kind of like the reverse of these two, right? So,
Yeah.
so that would mean that it would be coming down in here, going something like that. Does that make sense?
Hmm.
Okay. So I think that, Joe, was that you talking?
Yeah.
So a hidden line, I think, would be applicable there. Now that you say that, thank you for catching that detail.
Yeah. Thank you.
Good. Anybody else notice anything or have a question on any of the elements? Okay. All right, then I'm going to go back to my PowerPoint, see what we've got here. We're getting closer to the end here. This last slide just says that, even though we've been practicing sketching, it is that first step in the design process or in, trying to get your ideas in place. Sometimes when we're working in groups and we're working as a team and trying to find a solution to something, we all might have our own little ideas, and sketching is going to be your way to communicate your idea to be one of, if you would, the potential solutions that could solve a problem. But after we get done sketching, we're going to be using CAD. And in this case, you can see that they drew a model here that creates an assembly drawing for us, which then gets all the parts together. And then each one of those parts would have an individual, or what we call a detail drawing for it. That's going to be something that we're going to, continue to develop as you go through this program, actually. Okay. So I think that takes us to the last slide, and it does. So that means that takes care of chapter 3. So I'm going to stop the recording here.